Hey everybody, this is Larry. This is the Leetcode Biweekly Contest 29. So I'm trying this thing where I put the explanation in the beginning and then the screencast after the explanations. So some of the stuff I say may sound a little bit out of order. I'm still playing around with it. Let me know what you think about this format, whether it's better or worse or whatever. Hit the like button, hit the subscribe button, hit the Discord button, and you could start hanging out with Larry now. Okay, let's go over the problems. Yeah. Q1, average salary excluding the minimum and maximum salary. So because all the salaries are unique, you can actually do this in linear time by going through the array, finding the minimum and the maximum at the same time, and then just do a sum, subtract them, and then do this division. So that would be linear time. But since n is 0 to 100, and I was a little bit lazy, I just sorted it. This is only for contest. For interview, definitely do the linear time one. But so I sorted, and then I just subtract the max and the min, and just divide it by the number of elements divided over number of elements minus 2. So this, if you did this in, if you could get the min and the max in linear time. So if you did that, then that would be linear time, constant space. If you did what I did, then it's going to be a little bit more. Yeah, pretty standard problem. Q2, the k factor of n. So this, it could have been interesting, but this is because n is less than 1,000, you only have to do a linear search to count all the factors and then return the first k element or the kth element with a bound check that if it doesn't have k elements, then it's return -1. So you can actually also do this in square root of n times by just go up to the square root of n to count all the factors. So that is also another way, but because n is equal to 1,000, I didn't even have to think about it. So this is O of n times, which is not linear per se. It's just O of n times. Cool. And this is just brute force for that reason. You could go to square root of n, and then if you check the square root of n, then you get two factors, right? X and n over x, and then you can put it in an array and either sort it or just keep track of it as it goes toward the middle. And there's just an edge case about the square root, but otherwise you could do it in square root of n times. Relatively straightforward, but yeah. Cool. Q3, longest subarray of ones after deleting one element. Yeah, so this is sliding window. The key in there. So with sliding window, I always talk about invariance. And this is sliding window with invariant because you know that if you're having a window from a left pointer and a right pointer, or two-finger algorithm, you want to call it that. If you have two fingers and two pointers, inside everything in between, you have to maintain the invariant that there's at most 1 0. Meaning anytime there's two zeros, you keep on subtracting from the left until the at most 1 0. And then you just do and then you kind of keep track of the number of elements, and then you take the max minus the one that you remove. So that's how I got this formula: right minus left minus 1, because that's just the number of elements in between minus the one in the middle. And here we keep track of the fact that current, which is the current number of zeros, has to be at most 1. Because if it's 2, then it violates this condition. And why is it at most 1? Because if it's 1, then that's the number you delete. If it's 0, you just delete any ones because there's no 0. So that's kind of the reasoning. It's O of n times and O of 1 space. O of n because we just go through the array at most ones. You can see, even though there's two while loops, the right goes, we count the right side at most. Like this only happens once for every element on the for every element in the array. This also happens only once for every element in the array because we always increment left, right? So another way to think about it is we increment left n times, we increment right n times, so it has to be O of n. And we don't use that. We use O of 1 extra space, so this should be pretty good. Yeah. So this is O of n time, O of 1 space. A sliding window, pretty important. Comes up all the time in interviews and at least for Leetcode competitive programming contests. So definitely practice it. Cool. Q4, parallel courses 2. Yeah, so this one I took a long time thinking that it would be brute force / dynamic programming. And the main reason, to be honest, and I applaud the problem setter for this one, is because n is equal to 15. So n is equal to 15 makes it almost brute forceable. I mean, I did the math and it was very borderline not brute forceable. So I tried to do it in both Python and C++. Still was too slow. And then it was kind of a Hail Mary. And that's the problem with me and greedy problems is that is that greedy problems require some sort of proof, and because I didn't have a proof, I just kind of went at the end. I didn't have that much time left, so I was like, okay, let's just try greedy. Why not? So the answer is that is greedy. What do you greedy on first of all? So the greedy solution is that for every diagram, for every graph, the longest path is going to be your minimum number of semester at least, right? Because because you can only, if there's a longest path, let's say there's a path that there's a longest path that's of length x, it's always going to take at least x semester because you only take one at a time, right? So given that condition, you always take the class with the longest path, because if you take anything else, you still have to take this other class later. So that's my philosophy. It took a long time to come up with it, unfortunately. So yeah, so that's basically my strategy. I put everything in. So that's the greedy algorithm. How do you implement it? So the other part of it is based off topological sorting, and the topological sort component is based off that. Okay, we can only take. So there are two components for how we decide to take a class. The first element is that for each class, we keep track of the longest path. And you could find that using dynamic programming or something like that. So in this case, this is, the class 2, the longest path is 2. So we keep that in mind. And we only, so of all the classes that we can take right now, we take the class with the longest path, and then every semester we just take the most class that we can, given k is equal to 2. And once we set up those classes that we take, we just take them all at the same time, and then we clear things out. For example, in this case, for k is equal to 2, we take the class 2 and 3, and then now we can take course 1, and then after that we take course 4. So yeah, so I use a priority queue in that. For every element, if there's no, and this is graph terms, if the classes that points prerequisites, if there are no prerequisites for this class, or we cleared all the prerequisites, then we push it into initial heap for each x, for each class, and then we take k classes at once. So we try to take all the as many classes as we can, as long as it's less than k. So this is what this does. Though the x, we don't use x. Whoops. And we relax it all together by saying, okay, so here are the classes that we took this time, and this is topological sort, very basic topological sort, which is that once you take a class, then for every class that has this class as a prerequisite, which is what this graph does, we minus one of its prerequisites. That means that one of its prerequisites has been fulfilled. And once all the prerequisite has been fulfilled, we put that in the list of classes that we can take the next time around. So this is very greedy. I basically, if you watch the video later, the live part of it later, because I thought that because n is equal to 15, I could brute force it, and I tried to do different optimizations to kind of make the brute force work, but it didn't work because all you need was a greedy. So I say mad props to the problem setter for this one, for fooling me, because if it was like 100 or 1,000 or something like that, then it would be very obvious that it was greedy. So yeah, definitely well played for that. And yeah, that's what I have for this problem. So yeah, overall terrible contest, and I did solve this very quickly once I just decided to go for that as greedy. So, and I guess a lot of people did that quickly as well. Yeah, That's all I have for this problem. That's all I heard for this contest. I'm a little sad. This is gonna hurt my rating. Not that it matters, but I did learn that it was that greedy works. That is one of my weakest part of my game, if you want to call it that, is that I don't think greedy unless I really have to. And for this particular problem, they fooled me in that regards by making the end small. So well played, well played. Anyway, hope you had a better contest than I did. Let me know what you think, and I will see you next contest. Bye bye. Yeah, hey everybody. So I am doing code review because there's always an opportunity to learn, especially when you spend an hour on a problem. But it turns out that people did Q4 with dynamic programming as well with brute force, which is the way that I kind of did it. And so I just want to add an addendum to kind of how they did this contest, and it seems like in C++, if you made one optimization, which I couldn't prove, that is why, that was fast enough. I can prove that was fast enough, and that was good enough, which is that if you pre-cache the dependency graph or the dependency for a given node, that'll be good enough. Yeah, it's kind of a weird problem because if you did it on a contest, you can't do it this way in Python unless you make another optimization, which is what Alex did. If you made an additional optimization so that it's less than 3 to the n because you only choose the subset that matters, because he does combinations, then it's fast enough. But in C++, you don't need that optimization to make it pass, and I think that's why I didn't go for it, which makes this kind of, the boundaries made it a little bit annoying or tricky, because in C++ for this problem, you're able to solve it without that optimization that Alex did. So if you solved it in Python, or you try to solve it with bitmask, definitely look at Alex's solution with the combinations. It basically, yeah, that is really annoying actually, because I actually rewrote with that optimization in C++, and this is my solution from the contest, more or less. I just kind of re-added this part where I pre-calculate that, and it passed, right? And I got to pass. I don't know if this shows up here, but anyway, I got to pass. I guess it doesn't. This only shows up for contest, but yeah, but I got this to pass where I rewrote essentially the same thing, but in Python it was not fast enough. It was only fast enough if you do this thing that Alex did. I don't know if that's exhaustive because I didn't look at every solution, but that made this problem a lot more suspect. But greedy solution still works. So I guess it is what it is. Just one of those days where sometimes things just don't fall your way, even if you did the first 3 really quickly. And I did the first one in like pretty quick. I mean, one of the few people to have less than a minute. But yeah. So yeah, I did get a request to explain the bitmask solution. And it's not easy, but basically it's just brute force in a way. And I'm going to explain a little bit, but if you already got the greedy solution, then it's okay. But basically the bitmask solution, which works in a more straightforward, quote unquote, straightforward way in C++, but in Python it times out, and you need to make that additional optimization that Alex did. Immediately during the contest, I did think about both those scenarios, but I guess I just didn't believe in it enough, and it was very borderline, which is why this problem is a little bit weird in that regards, because there are a lot of borderline things with returns to performance. Because even if you had changed the n to 20, a lot of these bitmask thing won't work, and then so that's why it's a little bit weird, because they almost want to bait you into doing brute force, but not really. Anyway, so the bitwise solution is that okay. So first of all, what is a bitmask, right? Bitmask just for some visualization, bit mask is just a way to represent a number, represent a set by a binary number, right? Because you can look at, for example, let's say, you have elements from 1 to n, and let's say in a set you want to count 1, 3, 5, I don't know, 6, right? And then if you convert that into binary, you can just put, okay, the first number it's in the set, number 2 is not in the set, number 3 is in the set, number 4 is not in the set, number 5 is in the set, number 6 is in the set, right? So that's the bit mask. And there are a couple optimizations you need for this to work, so I don't know. I mean, I guess it worked for this problem, but it's still very tricky. But yeah, so basically the bit mask solution is that, okay, so given these courses that we have to take, what is the minimum classes that we have to take given that we have these courses? And the answer is that, and this problem is really tricky to do with bit masks. I mean, it's doable and people have done it, obviously, but it's just hard to do if you are not already familiar with a lot of bit mask or bit sets. But basically, given this number, this is just like, okay, let's say we have the number 1, 3, 5, and 6 classes left that we have to take. What is the minimum number of semesters left, right? So then that's equal to, well, given k, let's say k is equal to 2. Then we could just test, okay, let's take 1 and 3, so plus 1. So f of this is equal to, let's try this number, right? Is this good? And let's say that we can take 5 and 6 together. Let's say we're going to try, 1 and 5 together, say. I mean, this is a little bit constructed. So then we try this one plus 1, if that's possible. That's if taking 1 and 5 together is possible. This is if taking 1 and 3 together is possible, right? So you kind of enumerate all these possibilities, which is already tricky as well. And then that's basically the recurrence. It's just really brute force dynamic programming in that way. And you kind of enumerate this. And a lot of optimization deals with kind of answering this part of the question of if taking x and y together, or and if k is equal to 3, for example, then it gets even more complicated, right? And also you don't have to take two numbers with k is equal to 2. You can also just take one number. You try every possibility, right? And then you take the min of all these possibilities. You take the min of all these, and that'll give you the answer. So that's kind of the explanation behind the bitwise one. And it takes like 2 or 3 optimizations that, if you're familiar with competitive programming, you would know about these. But it's still kind of tricky. A lot of I don't think that that's the way to solve it, which is why the 15 bound is a little bit weird, because the top people did solve it that way, which made me a little bit sad, because I was this optimization away because I did everything else, but I just didn't think it was fast enough. But clearly I was wrong. All right, well, anyway, that's all I have for this contest. I think this is the actual end of the contest. I finished 558, which is terrible, but for me, because I don't know, I think it's just I've been on a bad streak, but it is what it is. Let me know what you think. Let me know how you did. And I'll talk to y'all, or whatever. Bye bye. Hey everybody, this is Larry. This is Biweekly Contest 29 on Leetcode. How's everyone doing? It's 10:30 a.m. here, which is not that early, but early enough for me because I didn't get enough sleep. So we'll see how that goes. Maybe I'm already setting an excuse myself. Hit the like button, hit the subscribe button, join the Discord channel, and let me know how you did. What was your favorite problem? What was your most hated problem? Leave it in the comments. Let me know. Okay. 7 seconds to go. Let's get started. Come on. And here we go. All right, part 1, or Q1. Average salary excluding minimum and maximum salary. So this problem seems pretty straightforward. I read it. The only thing that I double checked was whether elements were unique. That's kind of what I look up and down for. I was like, I guess it doesn't, and or what happens when it is not unique. But as soon as I saw that it was unique, it didn't matter. There's a linear time algorithm for this, but I just saw it because it was easier to type and not have to think about it. Probably wasn't even that much easier, but because I could just write min of that instead. But yeah, but pretty straightforward problem. Just take the sum of all the elements minus the min and the max, and that's pretty much all there is to it. Pretty straightforward. Cool. Q2, the k factor of n. So this one, the first thing I looked at after seeing this is kind of look at the constraints of n and k. Well, when I saw that n is 1,000, then I was like, okay, well, let's just do a brute force. I don't have to. So there was the square root of n1, but it's a little bit trickier. Not that much trickier, but a little bit trickier. And yeah, and basically I just do a brute force and just check all the factors, put in a list, and then return the k factor. You don't even have to put in a list actually, but I put it in a list, and then you just kind of check it. Longest subarray of ones after one element. So for this problem, as soon as I saw it, I knew it was sliding windows, and that is just moving the, you have a left pointer, and if you have right pointer, you're just moving it left and right. The invariant is that you have to keep the number of zeros to 1 0 or 0 zeros, and that's pretty much, what you're gonna see is just me kind of stop doing it for a second. But yeah. Yeah. Solved this one in like 2 or 3 minutes, so it's pretty straight. And I think I was taking my time to type it slowly because I was just, but I knew exactly what I wanted to for this problem. Yeah, and basically, as I described earlier on, hopefully, because I think I flipped the order these days. But if you're watching the live video, the explanation is later. If you're watching the explanation, then it may be before, depending on where I cut it. But either way, so the invariant is such that, yeah, you just keep, if we see a 0, then we keep track and we're okay, there were 1 more zeros, right? And then anytime we have 2 zeros, we have to move the left pointer until we get rid of that extra 0. And every step of the way, every step where we have at most 1 0, we just keep track of the length and then see which one is the longest. And that's basically what I end up doing. Yeah. Yeah, I thought that there may be an issue with running time because I click on submit and it took a long time to actually run. Oh, Yeah, and I was like, is this shouldn't like, and at this point I was just like, maybe my while loops are wrong because why would it take so long? But then as soon as I accept, it's okay. Parallel cost two. Parallel cost two. Q4. So yeah, what is this to say about this one? So this one, when I first read this, I was like, okay, I think I understand the problem. Um, and yeah, and I scrolled down. I was like, okay, I when I fixed saw this, I didn't know. I mean, I didn't know how to solve it per se. Um, and I was like, okay, this makes sense. This is just standard. You can only take up to K classes a semester. Okay. And then when I saw n is equal to 15, frankly, I was fooled. So well played, problem setter. When I saw n is equal to 15, I thought that I could do brute force. So it turns out that there's, roughly speaking, a 3 to the n brute force. Sorry, not brute. Well, brute force with dynamic programming, with bit masks, and there's a 3 to the n solution, or 3 to the O of 3 to the n times n, or something like that. But something that is essentially not fast enough, but barely not fast, or feels barely not fast enough. So I did that for about an hour. If you're watching this, there'll be a link below. I'll skip ahead to the greedy part of the solution, and I'll explain the greedy part as well. Yeah, click on the button. Click on the button below. Huh? Uh, Hmm. Hmm. A little slow down. Hmm. What is going on? Oh my God. Oh. Oh, poop. It's still wrong, but 1 and 2 at the same time. Yeah, let's worry about that. I struggled a lot with programming today. Hmm. Mm. It's fast enough though. Just not right. Come on. Still pretty slow, but to the count thing. That shouldn't matter, but still should be wrong though, yeah. One of those days. Why is one never good? Oh my god. What? Oh my. Wow. Larry's having a day. Made the same mistake a couple of times. Come on now, really? That's really tight. Let's see. Oof. That was the worst case actually, but guess that's fair enough. How do you do it then? Huh. I must be missing something obvious. Well, a lot of people got this, so I guess I'm just having one of those days where I'm missing the obvious. Well, you thought this would be fast enough, but I don't know. Maybe I do need more sleep. Can you do greedy? Hmm. Still pretty slow. Yeah, let's try greedy, I guess. I don't know. But why would they make it 15? That's the part that I don't get. Welcome back. So for this problem, for right now, to be honest, even for the last 5 to 10 minutes, I was just really thinking about it. Can't be greedy, can it? For n is equal to 15, like they wouldn't give a greedy problem if n is equal to 15, right? So that was my like I was out of ideas. I just couldn't think of anything else because I was like, okay, if it's not brute force, it has to be greedy or some sort of greedy. But I just couldn't. I was like, 15, n is equal to 15. This is, this has to be brute force, right? So I did really spend a long time convinced that it was not greedy because of n is equal to 15. I thought maybe there's some clever 2 to the 15 solution of something. But after an hour on trying to figure out dynamic programming and brute force and something like that, I was like, okay, look, Larry, you ran out of ideas. You don't. I mean, you just don't have anything else, right? Like if greedy doesn't work, fine, but you should at least try greedy because it might work, and then you tried everything, right? And I already at this point, you might not have seen me code everything, but I was in my head. I tried like for an hour, like different things to kind of get it to work, and I couldn't get it. So after that, I did greedy algorithm, and I explained this either later or before in the explanation portion. But basically, the greedy part comes from figuring out that okay, given the longest path of a course or like given the longest path of this graph, that will always be at least the minimum length, right? But we can't like that is the smallest minimum length of minimum semesters. So I was like, okay, well, I guess we could just greedy on that because we always want to take the longest path or the node that leads to the longest path. That's part of the longest path because why not, right? Because you have to take that class before all the classes that depends on it on this longest path. So basically, that's what I did. I did have a little bit dynamic programming on getting the longest path, as you see in this function. Actually, maybe I forgot. Actually, I guess it's a depth first search. You didn't need to cache it. I think I just forgot to cache it because I thought that I would just cache it. So actually, I'm glad that. Whoops! I only noticed this now. So in the explanation portion, I actually forgot about this. But yeah. So that actually made the complexity a lot more expensive, but somehow it still passed. So I'm happy about that. But yeah. So given so I was just thinking a little bit of what do I need to sort it by? Do I need to sort by the out degrees? I was like, no, I mean, not really, because if the out like even if a node has multiple or like a lot of out degrees, you still have to query it in some order because the longest path is the thing that matters the most. So what I do now is that for every class that we can take, we sort it by the longest path by putting in a priority queue, and then we just take the top k elements every time of the priority queue. So that basically we're taking k courses or up to a courses every time, and then every time we take those k courses, we free up new courses that we can take. And this is basic topological sort. But I actually didn't know that you could do greedy this way, so I'm happy to kind of learn about this today because I really thought that it has to be dynamic programming or brute force. Maybe I just haven't thought about this problem in a long time, topological sort, beyond the bare minimum. So I'm happy to kind of be reminded about this. yeah, at this very moment, I was like, okay, do I need another key to figure out what to sort this by? I was like, no, actually, for the heap, I just need the longest path, I think, for what I said about the out degree earlier. And then now we take we just go through the entire list and yeah, and we just take K courses at a time. Yeah. But yeah, but that's pretty much all I have, to be honest. Yeah, because as soon as I did this, I clicked submit and it worked, and I stopped thinking about it. It was very sad, but yeah, still, it is what it is. Yeah, let me know what you think. How do you did on this problem? How do you did on this contest? Well, I guess the other guy is still talking or going to talk, so listen to him, and bye bye. Gotta be. Greedy, really? Greedy, 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 greedy. Okay, fine. And once I decided on greedy, I got that in like 2 minutes. Yeah, that was kind of sad. Okay, well, this is a sad contest for me. But I don't know why they made it 15 though. I think so. A little bit meta, to be honest, is that I didn't believe it was greedy for a long time because n is equal to 15. So I thought that it was just some sort of dynamic program brute force. I got fooled by the meta. If I didn't know any better, I would have gotten it quickly, I guess. Or even if they gave it like, I mean, I give props to a problem setter, because if this was like 1,000, then it would have been greedy for obvious reasons because it couldn't be anything else. Maybe sorting, but well played, well played, well played, well played. And as soon as I decide on greedy, I got everything in like less than 5 minutes. I don't know. I mean, it's hard to kind of look at the top now when when it is greedy. But I did the first 3 in so quickly. What a waste. Though a lot of people did it really quickly. People even did it faster. So maybe it was, but I felt good. That's why. All right, let's go over the problem and problem set, and then ooh. Well played, well played. Well, that's all I have for this contest. I know that the order of the the video. It's a little bit weird maybe, but hopefully if you're still here, well, thanks for watching. Hit the like button, hit the subscribe button. Let me know what you feel about this contest, and I will see you next contest. Bye bye.